Live
Okay,
streamed.
got it?
Got it. Buenos
Mhm.
nebulous, stargazers. Hasta star clusters to all of you. It's the 69th episode of the Santa Barbara Astronomical Unit's weekly vlog podcast. Am I being heard? Oh, okay. It's the SBAU Astro Hour, emanating on this last day of spring 2022 from our man caves and computed ends by Zoom for some of our esteemed board members, and seen on YouTube by the club and anybody else that's interested in the astronomy. I'm the Baron Ron Heron, except I've stopped calling myself since I'm not on the radio. I'm just Ron Heron, the vice president. Proud to be. If you're watching 11 to noon Mondays, by golly, you're going to learn something. We just kind of like to get together like we used to do at a certain little cafe on Santa Barbara Street every Friday, and this is Monday mornings. We're going to talk today about comets and leftover comets, the meteor showers that either hit or don't hit. Moon is approaching Neptune while we approach summer solstice tomorrow, the 21st. This edition of number 69, SBAU Astro Hour, is from the 21st through the 26th. Guess where our moon ice may come from? We may talk about that. There was a quake on Mars, therefore it's called a Mars quake. And doggone if we're not going to learn something new that I didn't know about dark matter. But first of all, let's meet four. Well, if I put myself in the group, I don't. I'm not one of the the brain trust. I'm the guy that asked the question. I'm the little kid in Dr. Wizard's clubhouse on Saturday morning. Gee, Mr. Wizard, what is that? Here's our beloved president, Jerry Wilson, who's running the show. Jerry,
Hi.
married to the lovely Pat Forgy. Also married to a Pat, who happens to be our merchandise manager, is Chuck McPartland. Outrageously outgoing outreach coordinator, just combine those three words, and the beloved Tom Whittemore, editor of our newsletter. Doesn't get it to us, but he certainly puts it together every month. And then Colin Taylor, who I guess he's still around. I haven't seen
with
him.
a lot of help from Chuck.
Yeah.
I just converted to PDF.
Oh, you proofread it, Chuck. You find stuff in it.
That proofreads it.
Did everybody?
Oh, okay.
Did everybody convene Friday night at your old alma mater where you taught in the big observatory out there?
Yeah.
Sort of.
Yeah. So unfortunately, the telescope, I was not able to get it to respond to anything. So somebody parked it. I don't know who did it, below the horizon limits. And when it's down there, I'm not able to pull it out. So we didn't have the 8-inch that night. So I felt really bad about it. I worked on it for almost 2 hours, just trying to make it, work. But just finally gave up the ghost, But I don't know. Chuck can talk more about it because Chuck was there when I went home.
Yeah, Martin got his little scope and I had mine with the Melon Cam.
Mm-hmm.
So we showed people stuff. It was 60 some people, I think, that showed up.
Wow.
That's not bad.
67.
And it's parked. Is that what happens at observatories? They lower it?
Yes. So when you shut down the telescope, there's a command there that basically parks it, and the telescope aligns itself to zenith. Okay, so that the mirror is basically flat on its back. That's pretty important. I was not able to get it to respond whatsoever, either from the program or from the paddle. Okay.
Wow.
And so, yeah, it was pretty. I've never seen this before, Chuck. I've never seen it. I did get in touch with Ken, who was up in Alaska on a cruise.
Well, then you didn't get in touch with
He
Ken.
tried to help me from a distance, and his internet went out. He said the boat was rocking. That's all he said. So, he just suggested some things that I had already pretty much done, looking for target stars I knew were well above the horizon to try to take it out of its deep sleep. But no, I've never been here before,
I noticed when I was closing up at the end of the evening that there were all kinds of diagrams on the blackboard in there, or the whiteboard, whatever it is, black, I think, of the control mechanism for the telescope. So I'm wondering if somebody hadn't been fiddling around with it.
I think so. I think so. In fact, when I lit up the screen that night, Chuck, the main screen downstairs in the control room, it came up with kind of the symbol if somebody's not able to have a picture of themselves on Zoom, that kind of a picture, and it said observer.
Our beloved observatory at the museum is named after somebody named Palmer. Is there a name on the Westmont Observatory?
Well, it's dedicated to the folks who donate a lot of money, the Keck Foundation.
Oh,
okay.
And
I believe it's the same Keck Foundation that gave money to USC, and the facilities in Hawaii.
So they have a little name.
They call it the Keck Telescope, and there is a plaque upstairs, Ron.
The Keck, isn't that the big one that you just said? Fire burning?
So it's really funny when somebody says, "Oh, you're looking through the Keck," and it's only a 24-inch.
The big Keck is in Hawaii, Ron.
Yeah.
Well, don't say only on 24-inch. That's a big scope for us.
Yeah.
Well, since we were talking about it before we came on the air, what's the one where there's a fire burning and hopefully they're getting it under control?
That's at Kitt Peak. So
Keck and Kitt, I get those two confused.
Yeah, KITT. So Kitt Peak was dedicated, I believe, in the early 60s, and it's National Science Foundation put up the money. It has many, many telescopes on top, including the largest one. There's the Mayall 4-meter. Mayall, named after the two scientists, husband and wife. But the Mayall telescope up there houses now, different kinds of experiments go on with that 4-meter telescope. It's quite a big eye. And now they have in the last year or so, the DESI, DESI, which is the dark energy spectroscopic instrument. And it's an amazing program, that goes on. There's tons of scientists involved in this. And what they're trying to do is basically kind of clamp a lot of cosmological theories now into basically imaging simultaneously thousands and thousands, if not millions of galaxies in an evening, through these very, very fine cables. I think they probably are optical fiber cables, but they're very, they're about the width of a hair or something like that.
Sounds like a good topic to really get into in a future show.
We mentioned this several issues ago, about the DESI, just in passing, but it's quite a big program. And they're seeing galaxies out now to about redshift 1, which is pretty deep into the history of the universe. And
it's amazing how they align those little fibers. They get a metal plate.
Yes.
And they drill holes where the galaxies are going to show up in the view.
Right.
And then they attach the fiber optics to the holes in the plate, and then they put it on the telescope. Pretty amazing.
Yeah, Jerry, I didn't want to steal your show. I just thought, people.
You're not stealing the show. This is a legitimate astronomy topic. I read that the DESI instrument consists of over 200,000 custom components.
Yeah, and they're sort of worried whether the smoke might damage them. It's smoky in Tucson, which is about 45 miles away from the Kitt Peak. And when I was a graduate student there, I went up there many times. I used to race bicycles, and I climbed that thing on my bike many times. It's quite a climb. And the only thing I can think of is that they had to evacuate like 40 people. And the only way you can get off that mountain, unless you have a helicopter, is down the main road. Wow. And I think the fire was kind of on the main road. So, yeah.
Wilson is not anywhere near that. That's totally different.
No, this is around Tucson, Ron.
Oh, way down there.
Yeah, Wilson's around the Los Angeles area, which Jerry knows real well.
I thought there was a fire there not long ago.
Yes, there was.
The station fire, yeah. It almost clobbered the 100-inch Hooker, the Hooker telescope that basically gave us the expanding universe information.
I knew a 100-inch Hooker. Never mind.
No, that was $100. That's $100.
We got some silly stuff from the science cartoons that President Jerry Wilson somehow finds and forwards to us. So you call something up and I'll see if I can match it, and we'll read it together. Some of these are crazy, like Far Side cartoons, and Pogo and silly stuff. And a lot of them involve dinosaurs. Here we go, ladies and gentlemen. I wrote all this down. A bulb-headed stick figure is answering the phone. Emergency astronomer hotline. Can you describe the bright lights that you're seeing there, sir? The man on the line says, I don't know. Help. Stay calm, sir. Is it daytime? No, the sun is set and then these strange lights appeared. Could be the stars. Are they stationary? No, they're zipping around the bushes. Ah, they're firefly. Lightning bugs, sir. Tree blinkers, ground stars. They're fine, sir. Phew, well, thank you. That's it. We don't know much about them. But since they're too fast for our telescopes, I can transfer you over to the Weird Bug Hotline. Okay, thank you. Weird Bug Hotline. Is it biting you, sir? There it is. They make it out of stick figures and bulb heads. I don't know where you find them, Jerry. I don't care. I just like having them forwarded to me. Is there another one we could do real quick? You said you did 5. Do one of the dinosaur ones. See if there's a good chance this will have a dinosaur in it. Yep. 2 giant dinosaurs playing with rocks, and they've got them arranged in a circle. For the folks who often wonder about Great Britain's ancient Stonehenge, here's another new theory. A pair of humongous dinosaurs shown 65 million years ago sitting and playing, and one of them looks up and says, uh-oh, this can't be good. Incoming. Yeah, we had another cartoon about the incoming huge asteroid that wiped out the dinosaurs not long ago. I can't remember what it was. You have the Bed Bath & Beyond one, or would you know how to get it? No, it's the astronomers. Let's see where it is.
Astronauts.
Yeah, this is a dinosaur one.
Yeah.
Let's see, in the distance. Oh, that's Noah's Ark I'm looking at. Well, anyway, I'll just read this one off. Hello, Houston. We have a problem. Guess what we found on the moon? No, it's not a giant monolith from 2001. Even worse. We're having fun with those things. I'll leave it up to you, Doctor. You want to call one up, or shall we go right into some of our hot topics, is what they call it? And Bed Bath & Beyond. It's either a Stargate or the entrance of a wormhole, but there it is. I've always wondered. I've never gone there. But
Yeah,
now,
I missed that department.
yeah. Saw a cartoon once. The old lady was sitting on the toilet, and her son or whoever's with it, the family says, Mom, that's display. It's not the one they're going to use.
Yeah.
In the middle of the story. Okay. Summer starts. And I guess we all know how that happens. It's above the 23.5 degrees north of the equator. The sun directly hits Cancer, Tropic of Cancer, and then 3 months. We'll have no solstice parade, I don't think, this summer.
Yeah, there is.
Actually, they're doing it online, or are they doing it on Milpas? Do you know?
You know, that's a Tessa question, but it's happening next Saturday.
Tessa may be watching us.
So the sun will be, if we were at 23.5 degrees north latitude above the equator, then on this day at noon, the sun would be directly overhead. Right. But we're at about 34 degrees north latitude. So it's about 10 degrees, 11 degrees shy of being directly overhead. It's close enough, though. Your hat will shield, if it has a broad brim, will shield your face. So,
but it is the other end of that would be Capricorn, which would be the first day of the solstice of winter. Are those, let's see.
Oh, that'd be December 21st.
Do those spots on the planet have 4 seasons? Spring, do they still precede that?
Those define the tropics, and that's where the seasons just aren't quite as noticeable as they are up here.
Yeah.
Well, they're certainly they aren't on the equator. It's 6 to 6. You got darkness pretty much 6 o'clock to 6 o'clock.
For seasons, you should paint the equator with a very broad marker.
Yeah.
Yeah, right. Okay, well, happy solstice, everybody. Summer starts this week.
And they do definitely have, rainy and non-rainy seasons, even though they might not have that much temperature difference.
Yeah, we certainly don't have one.
Yeah, and with regard to the fire that we discussed earlier in Kitt Peak, Arizona, the monsoon season is projected to start later this week, which should take the fire.
Mm-hmm. Oh, it's hitting them anyway. got flooding in the street in Bangladesh again.
Yeah, Yellowstone is in big trouble up there north in Gardner, just the North Gate.
Yeah, that surprises me because all I've heard nasty about Yellowstone is the big caldera ready to explode, and all of a sudden it's a wash.
No, that's a bunch of hype. I mean, there is a big caldera there, and if it does explode, it will be very bad. But there's no way to predict a caldera going to blow or anything like that. So it's just an attention getter. Just the word for attention getter nowadays is clickbait.
But pretty much the whole park is like a crater.
Yeah,
an ancient crater.
Yeah, with a lot of lava there. That's why all the hot springs and geysers stuff.
Okay, the volcanic equivalent of a mega black hole in the center of a galaxy versus 10-star matter. Shall we talk about the moon passing Neptune? Just head out, gentlemen. Neptune is in Pisces, and it's about 8 degrees southeast of the asterism, the Circlet. 7 stars contained in that: Gamma, Theta, Iota, Lambda, and Kappa Passim. Circlet has 12 degrees south of yet another asterism, the Great Square of Pegasus. Do you have anything from your talking points you can call up, Mr. President? Picture?
I'm working on it here.
All right. The Pegasus square is formed by Beta, Alpha, Gamma, Pegasi, as well as Alpha Andromedae. Neptune's at magnitude 7.8, too dim to see, but you might be able to pick it up with binoculars, certainly with a smaller or larger scope. There it is, blue and gray with the little storms. The white spots are storms on Neptune.
Yeah,
Scooter.
now the diameter of the planet here is about 2 or 3 arc seconds. So you won't get this size of a picture with detail like this in an amateur scope. This was taken from Hubble data.
Okay. I thought that white spot went away.
Yeah, they
It
come and
comes
go.
goes.
Okay, but is it like the red spot on Jupiter?
In some sense, yeah.
Is it the planet, or is it Uranus that has the fastest winds?
It's Neptune that does 1,200 miles an hour.
Good Lord. And what are those winds made of? It's not oxygen mostly, is it?
Methane.
How about nitrogen? Nitrogen is normally a gas, isn't it?
Probably some of that, but I think the atmosphere is primarily methane. That's why it's so blue.
And are we looking at a polar cap?
No, that's a polar storm, maybe.
Yeah.
Oh, okay.
You're not looking at any solid surface anywhere on the planet.
I understand that. And therefore, would it be safe to say that in any stellar system, if it's a giant, it's going to be gas. If it's a small one, it's going to be a rock.
I don't know if you can categorically say that, but in general, yeah.
In general, that's all they're finding is giant gas planets, some of them real close to their stars.
Well, they're finding, gas giants. I guess they don't have good spectrometry on a lot of these things to know exactly what they're made of yet, but they're probably gas giants, just because things that big in our system are gaseous.
And anything the size of Earth or Venus or Mercury's not going to have enough gravity to hold the gas.
Mm-hmm.
So
for a while, but not long.
It escapes in the, okay.
Yeah. We'll get atmospheres like on the moon later. So
unless you have a hellacious magnetic field to hold on to some of it.
Okay. Are you any of you going to go out and try to get a shot there on Whittemore? You're going to try to get You're going to try to get Neptune and Moon in the same picture?
I saw the moon this morning. It's very pretty. It's almost last quarter. I also saw Venus come up. That was about 4:30, I think, something like that.
Right. Well,
they're still lined up. I don't know if we mentioned it last week, but they're lined up in the order of their distance from the sun, the visible planets.
Yes. The visible planets, can you name them? Mars?
The visual ones. Well, all the visible planets: Mercury, Venus, Mars, Jupiter, and Saturn.
And if you get up on a big ladder, Earth, you look down.
Yeah.
Now, the picture we just saw of Neptune is taken from the Hubble, which stands for Outer Planet Atmospheric Legacy Program, using the Hubble Space Telescope.
Now, it's not the one that's on its side, rotating sideways. No. That's Uranus.
That's Uranus.
But otherwise, they're twin planets, aren't they? They're about the same size.
Yep.
Similar in color and everything else.
Slightly more mass on Neptune, so it's actually slightly smaller in diameter.
And first seen close up by the Voyagers. One of them or both of them?
Both of them, I think.
They're still communicating with those Voyagers. Voyager 1 and Voyager 2 are out there past the Oort cloud, or are they still in the Oort cloud, you suppose? Doesn't matter, I guess. Comets.
I did see a cartoon that showed this guy who woke up in the future, and he was talking to a bunch of astronomers, and they got on the topic of the planet Uranus. And he said, we were always so embarrassed by that name. There's so many jokes about it. And he says, well, relax, we changed the name a long time ago. This is in the future. And he said, oh, what do you call it today? And he says, oh, we call it Eurectum.
Eurectum. Well, I saw your cartoon that named it Doug.
Doug, yeah.
Yeah. Mars, Jupiter, Saturn, Doug and Neptune. You have a lot of stuff in your talking points, Mr. President, about going to comets, leftover comet debris, that Herculean, let's see, what is it? Tau Herculeus meteor shower of about 3 or 4 weeks ago, end of May, was a bust.
Well, it was a bust, and it wasn't a bust.
Well, then what does that mean?
Our magazine considers it to be a spectacular show, but not from the number of meteors, but the fact that it had bright shooting stars, and one picture is shown there, which I will put up.
Valley of Fire State Park, Nevada, has a picture. Maybe that's the one you're going for. Tau Herculeus, is that the name?
Yeah. Herculids, L-I-D-S.
Mm-hmm. Herculids.
Herculides.
I can't read my writing.
Herculids, yeah.
Oh, there you go.
That's quite a nice meteor.
Mm-hmm.
That's the right timing and the right what do they call that? Centroid.
Okay.
Radiant.
Yeah. So
are you saying somewhere they did have a storm? Many?
No, there was no storm. Just they had some nice individual meteors.
Okay.
I consider it to be a dud, but the official magazines, Astronomy and Sky and Telescope, considered it to have been a nice storm. So.
And do you know when SW3, the Schwarzman-Walkman 3 comet passed through? Has it been years, weeks, days?
Well, it broke up in 96 or something like that.
Oh, that's
what this is debris from. Well, actually, this is debris from an earlier apparition, but in tracking the debris from 96, they figured out that we might get this from the previous one, I think it was.
So whatever the meteor showers, Leonids or all the rest, we get them once a year because we're going around the sun and that stuff's going with us. Of course, the whole solar system is moving. So
it leaves all the stuff that comes off of the comet is in orbit. It's in the same orbit that the comet's in. So it just populates the orbit with dust. And then every now and then Earth passes through some of these comet orbits and we run into all that dust.
And whatever sign of the zodiac is behind it, is where the radiant is.
It's not necessarily in the zodiac.
Oh, okay.
Hercules isn't,
Yeah, Perseids.
Yeah. Perseid.
So it's like going down the road and following a sand truck that doesn't have a cover over it, and the wind is blowing sand off, and you're running into the sand particles.
Jeez, Lord.
But you need to slow down and let them get farther away. In that case,
I had one quick question about debris off a comet. It could be water, couldn't it? Little ice crystals.
Anything. Yeah. Ice crystals are little solid things.
How does an ice crystal burn up in the atmosphere?
Well, Ron, what you're seeing is not so much something burning up as the object hitting the air at high velocity and ram heating the air in front of it, and the air fluoresces.
Becomes whatever that fourth state of matter.
Plasma. Becomes a plasma. Yeah.
Plasma. Got to remember giving blood. I used to do that.
Burning is technically combining something with oxygen, which may happen too. But what you're watching is, as Chuck said, it's the heating up of the object and leaving an ionized trail because of the speed it's going. There's apparently going to be another hypothesized meteor shower from the comet
Holmes.
17P Holmes.
17P Holmes, right? Bright.
Yes. In its and I had a nice picture of Holmes when it came through here that I got from my backyard. which is very similar to the one I'm about to show you here.
Look like a big jellyfish.
Yeah.
Well, it's giant hourglass, isn't it? Is it in an hourglass shape?
Well, no, that's kind of the debris field, but yeah,
Oh.
here's the comet.
There's the brightening stuff here is the bright coma of the comet. I don't know if that's a star or the comet's nucleus. I think it's the nucleus.
Right, the pseudonucleus, yeah.
Right. And so this is roughly what my photograph looks like. Mine's in color. It was a fairly big comet in the telescope. But the fact is, a couple of years ago, it had a sudden brightening. So a lot of the comets just come in and they give off their background trail and they fill up their orbit. This one had a big burst of activity and it sort of exploded particles out. Well, all those particles are in slightly different orbits than the comet is, but they radiated from a given point in the comet's orbit. And after a certain period of time, they still have a periodicity, those particles all come back to that same point in the orbit, or a new point in the same orbit. And if the Earth sees that, goes through it, we will see all that stuff as a big meteor shower. And that's what's projected to happen.
How come it's not a tail?
Well, it is a tail, but it's not pointed away from us. It's pointed right at us.
You just put the monolith from 2001 across half our screen.
Sorry.
That's all right. Still getting it down. Okay, that's fascinating. But where does the hourglass come in? I got all your notes.
Yeah.
That's kind of the shape of the debris field.
Yeah, in its orbit. So it's like if you take and you draw an ellipse on a piece of paper, and then at the point where the comet had a big burst, then all that stuff spreads out along the orbit, and it comes back to a point at that same point in the orbit. So that's an hourglass. The shape it expands, it bulges out, and then it comes back together. And so when it comes back together and we pass through that part of the orbit, we should see it. Let's see. Oh, there it is. Holmes tail of debris.
Yeah, I don't think they're predicting any kind of outburst of meteors from this, but they're just saying that it'll be visible.
Yeah. So this shows, very barely shows, but you can see that this is from Comet Holmes, and it shows the trail of debris starting down here in a sequence of things. And you can follow it if you have a good imagination. You can follow it all the way up through these frames. These have been reproduced so many times, we probably lost the subtlety of actually showing the trail. I can pick it up there and some other places. So.
Okay, the last time it went by us was October 2007, but it was first discovered in 1892 by Edwin Holmes.
Yeah, you know Eddie.
Eddie Holmes, as he was observing the Andromeda Galaxy. Well, look at there.
Caught his attention.
So
one of the distant cousins of Sherlock.
Sure.
He had two brothers, Mycroft and this guy Eddie.
Well, what you showed there, the picture looked like a small version of an elliptical galaxy, one of those big cotton.
Well, it does. It looks like a spherical galaxy.
Yeah. So when it says the largest comet outburst, that doesn't mean a meteor shower. That just means what we saw.
No, it just means, an eruption of particles, a bulge in debris from its orbit.
Well, maybe
I think one of the speculations at the time was it was a body that was full of voids and caverns, and one of those collapsed, and then it just poofed out a bunch of stuff.
But we get a meteor shower only when the comet crosses our orbit, and we're not in that.
When the debris donut crosses our orbit.
Yeah.
Otherwise, we'll never see anything. Or can you still see the comet though if it doesn't cross our
orbit?
Yeah,
we can. Yeah.
Well, you
still see the comet, and we can see meteors independent of any comet that we know of.
Well, whatever struck the James Webb Telescope, you suppose that was a leftover comet or just a little speck going through space?
I don't know.
Who knows?
Tiny little mini Oumuamua way somewhere. Okay, well, Let's wrap up comments with the European Space Agency. This was interesting. They got a mission. They're looking for a big rock with a tail. They're going to go inside the solar system, the inner, and launch, I guess, in 2029. And they're going to pair up with the ESA's aerial exoplanet mission. I don't know how they're going to get those two together, building on the success of the Rosetta and the Giada missions, where they went out for a time and visited, what, an asteroid?
Comets.
Yeah.
A comet, okay. Comets
Giada went to Halley's Comet, and Churyumov-Gerasimenko went to another comet. I can't remember the name now. Oh, Churyumov-Gerasimenko was what the comet that the other mission went to.
Well, this will be the Comet Interceptor mission. I guess
Yes.
we're connected.
The news note of today is that the mission's been approved for funding and is expected to launch in 2029.
Okay.
So they're going to just kind of hover out there in a parking orbit and wait for us to see something that seems to be coming in that's interstellar or an interesting comet, and then they're going to go visit it.
Right. They think they've seen the previous missions have visited older comets that have been into the inner solar system many, many times. What they're looking for in this one, as Chuck points out, is new comets that are coming in for the first time from the Oort cloud.
Well, are they going to land on it?
I don't think they're going to land.
I think they're just flying in formation.
Yeah. Landing may be tricky because there's a lot of crap coming off, especially with a new comet. It's going to be quite volatile, I think. Might be pretty. It's like trying to land in a rocket motor.
And ESA launches from either what, South America or Australia? They have
Aerial launches from Ghana and northern South America.
Guyana, yeah.
Guyana, yeah.
Is France involved? Or are they part of ESA? France?
Yeah.
Okay, but they don't have a place. They use the same one Britain uses. Ghana. They must have a hell of a.
Well, no, British Guiana is European Space Agency.
Yeah.
Woomera down in Australia was, I think, the British Defense establishment, or might have been their science establishment, but not part of ESA.
United Kingdom. Okay, gotcha. Well, that's the Interceptor, and that kind of brings me, if you don't mind me jumping around, let's see, where is this other? We had a Mars quake. You want to talk about that? Did you read it about a 5 magnitude? They use the word magnitude on tremblers as well as brightness of stars. Happened on May 4th. This time it was NASA's InSight. I got confused and thought it was the Perseverance and the Ingenuity copter was involved, but no, InSight was earlier, and that they have a seismometer on board. I guess they all have those, probably.
Yeah, Ron, we felt it here. Not over a yogurt jar at the refrigerator.
Well, I don't know why I smell freshly baked sourdough bread every time you go on the screen, Tom.
Good sniffer. Tell me what kind of bread I baked this morning, Ron.
Rye.
With?
Whiskey.
Buckwheat, with a little bit of buckwheat. And raisins and walnuts.
Jeez.
Sounds good.
Can we put our ovaries? Doctor says I'm not getting enough carbs in my diet.
So the moonquake or the Mars quake was the biggest Mars quake recorded by the satellite. Satellite, not the satellite, but the lander. Yeah, lander InSight. And it happened about 1,000 kilometers away from the probe.
Really?
Yeah, and they're going to terminate the mission. They're going to retire it now. The satellite, the lander, has accumulated so much dust on the surface that the power level is so low now, and they're not getting the dust devil effect to clean them off like that they would hope.
Yeah. Well, you know what they're going to have to develop. Are you way ahead of me on this, Whittemore? Wipers. We can have them on our car. We can put one on our lander.
Yeah.
But Red Planet doesn't have plate tectonics, as far as I know. Am I wrong on that?
Certainly not very much, if there's any.
Yeah. Well, what this is, they think, is either meteorite strikes will cause some of them, or because the planet's smaller, of course, it cooled a lot quicker than we did, and the crust is shrinking, but it's rigid, so it cracks occasionally. So that's what's causing these.
Mhm.
So anyway, I misspoke. They're not going to turn it off, but they're plotting the power curve, and they said it will become defunct by the end of this year. So it's going to turn itself off, unless someone shows up there with a whisk broom.
Yeah.
Should have outfitted it like they did the Voyagers. They're still sending back dinky little radio waves from God knows way out there.
Billions of miles out. Boy, those are faint signals.
But they're not powered by solar panels.
No.
Oh,
No.
They're powered by plutonium, aren't they?
Yep.
Yeah.
How in the world did they get those off? So Mars quakes. Okay, fascinating stuff. Originated near the Cerberus Fossae region, 1,000 kilometers away. That's kilometers, so it's about 700 miles. But that's and interesting. This is, what do you got? I'll go where you go, Jerry. You call it up. What is it? Oh, is this the
ice on the moon?
Ice on the moon. That's what I was going to go, but I don't have many details. Maybe from lunar volcanoes.
The article is there. I sent it to you. It's from Science News, which I subscribe to.
Right.
And the idea, it's very interesting, was that the moon had an atmosphere in the past, temporarily. And I've heard that before from other events. After Apollo landed on the moon in 1969, a news guy was talking to, I think, to the science guy about it, maybe Carl Sagan. And he said, the moon doesn't have any atmosphere. And Carl went, yes, it does now. The exhaust from the landing is now the moon's atmosphere. But it will slowly dissipate away because it doesn't have a magnetic field. So the solar wind will blow that atmosphere away. Well, apparently in the past, and the idea of this article is that in the past there was volcanic activity on the moon, because you can see the Maria, which are vast lava beds or seas that have frozen over. When that stuff came up to the surface, whether it was like the Yellowstone caldera that came up over a big area, or it came up in certain small mountains, that gave the moon an atmosphere of the exhaust gases from the volcanoes or from the lava. And a lot of that would contain water. And so the moon actually had water in its atmosphere for a period of time. The water condensed as ice in regions where the craters are permanently in dark at both the South and the North Pole. And so this is what you're looking at, is a map from that study, a computer simulation. And these are suggested areas at the South Pole, which is more icy today because it has more cold traps, where temperatures can keep water frozen for billions of years, longer than the North Pole. The North Pole has fewer of these shady regions.
And not delivered to the moon by comets like they think happen on the Earth?
Well, some of that would happen too.
Yeah.
And
this is not the only source. Comets could be a source too.
So you just told me something I didn't know. If you have an atmosphere, it means you have a magnetic field, and therefore Titan, Saturn's moon. That's not the reason?
A magnetic field helps you keep an atmosphere if you're in the presence of the solar wind, but it's not a prerequisite.
One of the moons of Saturn, I think it is, maybe it's Jupiter, is bigger than our moon. Enceladus?
Titan.
Titan is bigger?
Yeah.
Titan on Saturn is bigger, and Ganymede and I think Callisto on Jupiter are bigger.
Yeah.
Do they all have atmospheres?
I think they call them exospheres. They have very tenuous, like especially Io from its volcanoes has a very tenuous, like sulfur compound atmosphere.
Well, correct me. Go ahead.
There's one moon on Iapetus, I believe, that's black on one surface and white on the other one. And the white is the black is the normal color of the moon. The white is because it's trailing another moon that's blowing off ice crystals.
Actually, it's the other way around, Jerry. It's the white is the icy substrate on Iapetus, and the black is polycyclic aromatic hydrocarbons that have come off some of the other moons.
Okay, well, I get credit for a good try. I had a 50-50.
Well, my understanding, correct me if I'm wrong, is that what used to be our 9th planet, which is now a dwarf planet, is smaller than our moon, but has an atmosphere, right?
Yes.
It sometimes has an atmosphere, the belief is.
And
Sometimes,
I think it's little moon Chiron or Charon.
Sharon.
it has 4 moons,
5.
5.
But doesn't Charon have an atmosphere of sorts?
It probably has a small exosphere.
And yet our moon can't maintain one.
Our moon has sort of a very, very, very tenuous one.
Okay.
And also there's this periodic effect that happens as the terminator sweeps over it. And you get the sudden heating that it causes rocks to exfoliate. They kind of crack, and there's an electrostatic effect too that raises a little cloud of dust that kind of follows the terminator as it goes around the moon.
Jerry, the 2 pictures we're looking at now, the 2 circles, those don't represent the whole moon, do they? They're sort of like the equivalent of an Arctic Circle on the Earth.
Exactly. Yes. South Pole and North Pole.
Because the sun would evaporate all the rest of them that go down where we landed our Apollo craft, for example. There'd be no water.
Well, as just a second aside here, we have an 8-month-old kitten here, and it's having a running fit in the house.
Did you say a chicken?
No, kitten. K-I-T-T-E-N. If you've ever had a kitten that had a running fit, it can get very exciting.
I had to get rid of my cat. Yeah, it was giving me terrible diseases.
There's actually an acronym for that. It's something like transient frantic activity periods, TFAPs, or something like that.
Well, we don't hear it until it goes in front of you like at Chuck's house.
Oh, it shot right under the computer, and I'm mentioning it because it might unplug something as it goes by. So, if I wink out, that's what happened.
Last question I have, or at least comment before we leave that topic, is I wonder if you could ice skate on the moon.
Well,
the poles, are they out like a frozen lake, or is it mixed in with dirt and crud?
There's probably dirt mixed in, but you could see on that diagram it was saying, 300 meters of ice, the thickness in some of those craters.
It's like a frozen lake. Ice. Wow, like a frozen pond. Our moon's ice. Who would have known? Are
so
they going
to? Ron, I was going to say, while we're still on the moon, did anybody see a week ago Sunday that beautiful moonrise, the strawberry moon?
Yeah.
Yeah, it was beautiful. So it turns out my brother-in-law was visiting, and he took a photo of that thing. It's incredible, and I was thinking of putting it in the next newsletter.
Great.
Okay. Yeah.
Very, very pretty. He took it with an iPhone 11, and it's amazing how much better the photography is
the
on the
phones are really, yeah.
Yeah, it's amazing. Yeah, it's real pretty, Chuck.
But it wasn't strawberry colored. Was okay. It's yellow though, isn't it? It's not red.
It was, I think it's called the strawberry moon because of the strawberry season.
That's what I heard. Yeah,
it sure looked kind of pink red to me.
What are we looking at, Mr. President? Can you enlarge
ending our comet tour for today. This is comet Pan-STARRS, and it's near an open cluster IC4665 in Serpens, or is it that Serpens is down there? I can't tell if this is, yeah. So this is on this particular picture is from a planetarium program for June 23rd at 9 p.m. This is east and southeast. So this is rising. Pan-STARRS is of note because it's going to turn in this week, this period, it's going to turn from having a tail on one side to having a tail on the other side. So in between, it's going to have a tail that points, I think, directly at us, or if it's in the east, it has to be pointing away from us because it's pointing away from the sun. So this is an opportunity to photograph it before and after its tail transits. And IC4665 is a nice little open cluster.
That article also implied it had a fan-shaped tail, which means when it does this transit, you might end up with little spikes of tail on either side for a while.
Yes.
E2017 K2 is pan stars. And let's see, hour after sunset, it'll be 30 degrees high, climbing just over 2.5 degrees east-northeast of magnitude 2.8. Carbajal? No,
Sebelrai.
Cabelrai. Okay, it's an I. Beta Ophiuchi. So
These star names are fun.
What?
These star names are fun.
Oh yeah, especially Ophiuchus,
Yeah.
which I lived my whole life not knowing about. Wow.
So leaving our
It's a constellation though, Ron.
Okay.
leaving our comets behind.
Oh, these are the lined up little dwarf galaxies.
No, this is the NGC objects within a galaxy.
Oh,
That's really something.
This is a northern Ursa Major. It's pretty much up all year. It's a summary at our latitude.
Is this 100?
Yeah, 101.
101. Okay.
Yeah.
The pinwheel.
I've got that thing memorized. It's got this kink right there because I fought so much to get a good photograph of it and processing. I accidentally memorized everything in it.
I showed that Friday night at Westmont with the Malencam.
Okay. Could you see much beyond? Could you see these arms out here?
Yes.
Okay, good.
It was a decent night.
Yeah, it's a bright Messier objects. It's easy to find, easy to see. It's up in that rich galaxy field around the North Pole. But I've always been intrigued by this. It has other nebula in that galaxy that are star-forming regions. There's red nebula that are excited and emitting their own light, and there's blue nebula that are shining by reflected light. This, I don't know, that might be that could be a nebula, it could be a globular. It's pretty big for a globular. NGC 5455, I got to look that up. But that these things are big enough so that they have been spotted or photographed before. It's interesting to see. A lot of these, Andromeda has a number of these things, and the galaxy in Triangulum M33 has a lot of super big red hydrogen alpha regions.
Well, a lot of this is from Herschel making what became the precursor to the NGC. And he couldn't see the spiral structure in the galaxy, but he could see these individual bright knots. So they got separate names.
So they're either gas regions where dust can make future stars, or they're clusters of already stars, star clusters. Yeah. But they look the same. Wow.
Yeah, I remember the first time I saw this galaxy was at Lassen with my 18-inch. It was kind of like a maiden voyage for the 18-inch telescope that I built. It's a beautiful galaxy.
Yeah.
Well, we've been talking about clusters, and maybe I missed this if you guys said it. Do most clusters, if not all of them, have a black hole in the center?
You mean galaxies?
Yeah,
no, the clusters.
You mean the
star clusters? Yeah, in our galaxy, in any
the globular clusters.
Globular clusters, are they like mini galaxies in that there's not a supermassive black hole, but
there's a lot of unknowns about globular clusters. They're stable over long periods of time. They're very old stars, so they're very old structures. They don't orbit in the plane of the galaxy. They orbit in a sphere around the galaxy.
And a fair number of them do have mid-sized black holes in the core.
They do have them. Some of them are very stable. Some of them are disappearing. That is, in their orbit around the galaxy, around our galaxy, they leave a trail. They populate stars in their orbit, so they fill the ring of the orbit up with stars that are being drug off the globular cluster. And that can only go on for a certain length of time, and then the globular's gone.
But
so
they've given an NGC number to every one of these in one galaxy out in the distance?
Just these. There's a lot of things in there that you can pick out as nebula that are not independently labeled.
NGC stands for what?
New General Catalog.
New General Catalog.
Okay, so there's far more of those than there are Messiers.
Oh yeah. Look at the numbers. The 5,000.
Messier wouldn't have been able to see what we're seeing now. These circled.
I think the NGC goes up through 7,000 objects.
That sounds right.
7,000. Good Lord.
I know there's a 7006.
Excuse me.
I know
This is
there's a
now.
7006. Okay,
Yeah.
so it goes up there.
Well, now I know you've
I
talked about it.
suspect this is one too.
Say again. You're allergic. You're allergic to cats.
Must be. He left a vapor trail of cat fur.
That's right. You're going to have little mini meteors happening in your room anytime. Do I? Is my
This looks
understanding
like a
what?
this looks like a nebula region too, and there's faint arms out here.
Mm-hmm.
What is that blue dot in the lower
I
left?
can never find the mute button fast enough.
Wow. One arm goes way out into space.
Yeah, yeah. This one's got a right angle to it.
Mm-hmm.
Well, not exactly.
And there's a lot of debris back here. I think that this one has been a victim of a nearby, a
Yeah.
passerby, a drive-by tugging with the gravity. Okay.
Well, you do have a couple of colliding. Let's see if I can find the Centaurus A with no dark matter. Somehow they've determined that two galaxies either collided or in the process of colliding over 100 million years. Two into one, got a big S shape. Do you know what I'm talking about? Centaurus A, one of the brighter galaxies, but no dark matter. First time scientists are mapping out the invisible magnetic field. How in the world do you map
Oh,
out
the magnetic field. Yeah. Let's see.
using infrared light, initial collision of the spiral and elliptical galaxies? Observations made by NASA's Airborne Stratospheric Observatory for Infrared Astronomy, called SOFIA. This sucker's 13 million light years away. There it is. Wow.
Now this is a picture of a galaxy we've all seen, but not with all the fur on it. The fur is due to the magnetic field lines. It illustrates, and the magnetic field lines are determined by polarization of the light. And SOFIA is at, I think it's a 30-inch or 60-inch telescope that's mounted in the side of a Boeing 747.
Right.
And there's plenty of dark matter in this galaxy, Ron. That dark matter, absence of dark matter, is talking about that other lineup of little galaxies.
Yeah,
That's in the
we'll get
next
to that.
article.
Oh, the little ones. Okay, got it. I misunderstood. So
This one's got a huge black hole at the core, and that's the jet coming out that you see as that S-shaped thing.
Yeah.
So it gives us a butterfly effect to two wings, upper and lower.
Yeah.
Yeah.
But if you saw it, are we looking side on to the galaxy itself?
Yes, we are.
Oh,
It seems to be a collision between a spiral and an elliptical, and that's the remnants of the spiral disk there.
Yeah.
Okay. Trying to grasp all this. An elliptical galaxy to me is like a large version of a star cluster. It's not a flat disk turning.
Yeah.
Yeah.
Just a ball of stars. And yet something you just said to me a while ago makes me think, well, then a lot of them must collide. That's how you make black holes.
Yeah.
A lot of them, yet that's something we never see hardly. We might see what, a supernova every 100 years, but we never see.
Ron, every night you can see hundreds of supernovae if your scope is big enough.
Well, then it happened. You don't see the initial blast, though.
Some of them get caught early enough.
Does it take days for the explosion? Is it like slow motion? Because
no, it's milliseconds for, depending on the size of the star. It could take 15 or 20 minutes for it to happen in a really big star.
Okay, so when it collapses, if we saw that, it would just disappear from our telescopes until the next instant. You'd be able to see it, you suppose? Because
the collapse is happening in the core, and then a shock wave goes out into the outer layers. But if you have a really, really massive star, it could just wink out without the supernova explosion into a black hole.
Well, I swear, I thought I read that once a century, we get one in every galaxy on the average.
In any given galaxy, yes, like ours.
Yeah.
Where the star formation rate is at a certain rate. But if you're looking for supernovae, you can find them because we've cataloged trillions of other galaxies. So you can find lots of them each night.
I don't know how they see the stars. They can barely see the galaxies, let alone.
Right, but when they go supernova, they get brighter than the galaxy.
Okay, what are we looking at here, Jerry?
Oh, this is possible cosmic debris from a galactic collision.
Those aren't the dwarf galaxies?
Well, these galaxies here, this is a spiral galaxy, this is a spherical galaxy. These are not the debris. The debris is the little pinpoint that's in each of these boxes.
Little squares.
Things that, when two things collide, there's not, it's not like two solid objects running into each other. They're mostly empty space, but they will feel this because of the new stuff coming in. They're no longer in equilibrium and happy with the gravitational fields that they're experiencing. So some of these objects get accelerated, and they get accelerated out of the galaxies. I saw a visualization. I'll try and dig that up. It's really interesting for next time. It shows the collision of the Andromeda galaxy with the Milky Way, and produces a galaxy they call Milkomedia. And but it's what the collision will look like from the Earth as you observe it. Now we don't know, it's a lot of variability in the input, so we don't actually know what's going to happen. But among the possible outcome, it's sort of a Monte Carlo analysis for those of you that know what that is, taking variations of things. And one of the things that appears to be fairly common is likelihood is that the solar system, including the Earth, will be flung out of the Milky Way, and will not after that be in any galaxy, so to speak. And so that would be a trail of debris that we would be part of then after this collision. But that's 5 billion years in the future, and by then the sun will have grown and swallowed up Earth possibly, or at least made it uninhabitable here. So you don't need to worry about, losing the galaxy at night.
Selling my home.
Yeah.
And moving where?
I have a picture of one of those simulations of Andromeda colliding with us. If I can share that one.
Sure.
Go ahead.
Okay, I can't screen share while you still are, Jerry. So.
Oh, sorry.
All right, here we go, and I'll need your permission, I think.
Got all this high tech that I have no idea what they're doing. Oh my God, look at that.
Yeah.
Above a mountain.
Yeah. Well, that's a view from the Earth,
Okay.
This is what the new Milky Way would look like at night.
Yeah.
5 billion years from now.
And in the process of the collision.
Right.
Andromeda would be the upper one, the upper right.
Yeah.
We're the lower left.
Mm-hmm.
Okay. So chances are low that any two stars, one from each galaxy, would ever collide head on. They'd probably just become binary if they're close enough, right?
That's tough to do.
Yeah.
Well,
two stars coming near each other, they have to have a third body to soak up some of the energy. So one of the third body has to slingshot around, take energy away from the other two, so they would fall into a mutual orbit with each other. Two objects that are not initially in orbit with each other would not enter orbit with each other.
It would have to be really perfect conditions for that to happen. Yeah.
Right.
Huh. But the few examples of gravity waves that we're getting is actually two neutron stars or two black holes finally doing it, but they spin like crazy before they merge, don't they?
Yeah.
But that's as rare as a supernova, isn't it? If not rarer.
Yeah.
It's like in the world of physics, things don't want to hit. They're just too vast, and the space is too large, and therefore they just want to circle and dance. Interesting stuff. Yeah, our last speaker, Professor Darvish, said something about red and blue galaxies. Supposedly he was talking about evolution of galaxies. Did you understand what that meant?
Redder are older and bluer are younger because they have more young blue stars.
Oh, okay. But they don't give off the color necessarily.
Well, that's the color they kind of look if you sum up the wavelengths that you're seeing.
Oh, because they're new, they give blue. They give more.
They have hot young stars, and those stars are blue, so there's more blue light in the spectrum.
More ultraviolet. Okay, and it has nothing to do with the receding, the Hubble constant, red shift.
Not really.
Well, this has been great, guys. Is there anything we missed? When many collide?
I think we covered most everything.
Yes, we did. And I will say this, because I did write it down. Our science speaker, ladies and gentlemen, in 2 Fridays, a week from this Friday, for the SBAU general meeting at night, Friday the 1st of July, will be Dr. Robert Zellum from NASA and JPL talking about future missions and something about life on exoplanets. Anybody know what happened to Bruce Murdoch, who's usually our 5th picture? Is he okay? He's back in the hospital.
He seemed a lot better last week.
No, he had an appointment this morning and he wasn't sure that he would get complete that in time for this, and I guess he didn't. So he sends his apologies.
Okay.
Now, we did not cover Cygnus, the swan, and the rich stuff that's in there. So I encourage anyone who has a scope. Cygnus is well worth looking. It's just a rich part of the Milky Way.
Right.
Go out. It's right overhead in the evening, and you will enjoy it.
Rising in the evening on the ecliptic. You did it. Say hi to your wives for me, the 2 cats and Maureen, and happy beginning of summer and end of spring. I hope it's not too hot, and let's put that fire out at the Keck. And we'll see you next Sunday morning, gentlemen. Thank you for convening with us. We'll do this again. You can watch online. Number 70 is next week. SBAU Astro Hour. Later.